All right. In the previous video, we started talking about factoring, kind of in the terms of it being reverse distributive property, and that's a really appropriate way of looking at it. So we are going to start just working through a bunch of different kinds of examples, and we'll get into some other things. But for this video, we're going to look at some pretty simple examples where we're just looking at what do we do when we have just 2 to 3 terms and just one variable. All right. So we've got these 3 examples right here. All right. So let's just kind of break each one of them down. So on this one, I've got 14c squared plus 2c. And so what you're looking for is, first of all, with the numbers, it's what's the smallest number, or what's the largest number, sorry, my bad, that goes into both of these terms. And so it's kind of, yeah, it's like greatest common factor. You know, that's the term we call it, right? GCF, greatest common factor. I got to get off of that here and get the black going here. GCF, greatest common factor. And so the greatest common factor of 14 and 2 is 2, because I can't do anything bigger than 2 and 2, and 2 does go into 14. Right? And then you do the same thing with your variables, all right? And so the thing is, I've got 1c here, and then if you think of this as like 2 c's, right? That's what the variable means, right? C squared is just c times c. So I've got 2 here, I've got 1 here. So the most I can take out of both of them is 1. I wonder if you guys hear that on the video. It sure is loud in here. So I've got 2c is what I can take out of each of these, all right? So what I'm going to do now is I'm going to set up my parentheses. I know it's going to be plus because I have the sign right here. And then let's start with this. What number do I have to multiply by 2 to get it to be 14? Well, I'd have to multiply 7. And then I have 1c here, but I have to be able to get to 2, so I'm going to have 1 more right there. And then when this term is the exact same as this, you just basically multiply by 1, right? Identity, right? Multiplicative identity property. Multiply 1 times anything, it just gives you that, and it's kind of useful in this case. And so this is a completely factored form of this, right? And so now let's try another one. So if I look at this one, 4 plus 28y, right? Well, I know 4 can come out of 4, right? That works. Does 4 go into 28? And the answer is yes, it does. It goes in 7 times. Now a quick word. Factoring is really difficult if you do not know your multiplication facts. And if you don't know your multiplication facts, you owe it to yourself to do something about that, right? Because it really makes things a lot easier in math if you're not like counting on your fingers or like trying to figure things out or pulling out a calculator all the time for really simple calculations, right? So that being said, let's get back to this. So we're going to have 4 out front. There's no variable here, and there is one here, so I can't pull a variable out, right? So it's just the number. And so 4 times what equals 4? Well, 4 times 1. And then I put my plus, and then what do I have to multiply by 4 to get to be 28? 7. And then my y comes right here, comes down. And then what you can always do if you don't trust yourself is you can say, okay, well, let's multiply this. So 4 times 1 is 4, right? And then 4 times 7y is 28y. It doesn't really look like a 7, does it? And then, so 4 and 28y, which is what we have up here, right? So, worked out. Okay, this last example here that we're going to do. We have 15x cubed plus 24x to the 5th plus 9x squared. All right, so same thing as this is, let's start by looking at our numbers, right, our coefficients, and see what can we pull out of all of these. Well, I can't pull 9 out because 9 is, it doesn't go into 24 or 15. But all of these numbers, this one, and this one, are all divisible by 3, right? So I know I can pull 3 out. Now, what you always look at is you say, okay, does each of these have an x variable? Yes, each of these has an x variable. So what's the smallest number that you see out of them, right? Well, the smallest is this one has 2. This one has 3, this one has 5, but this one has 2. So that's what I can take out. That's the greatest common factor of the variable that I can pull out, right? Sorry, that looks like an asterisk, and we don't want that, right? So I can pull 3x squared out of all three of these terms, okay? So what do I multiply by 3 to get 15? 5. And then I've got 2 x's, and I want to get to 3, so I'm just going to have 1x. You go plus, what do I multiply by 3 to get to 24? 8. So I've got x squared here, and I want to get to x to the 5th power, so we're going from 2 to 5, so I need 3 more. Sorry, I wrote the wrong thing. I said the right thing, but I wrote the wrong thing. I need 3 more, right? And then I also need to rewrite this, all right? And then, or sorry, that was the squared. This is not going well, guys. All right? So then, let's do the last one, right? And then plus 3, because 3 times 3 is 9. And then x squared, I've already got the x squared deal with, and this is x squared right here. So we're just going to go like that. And my completed factor form, I'm going to write it so it looks a little better. Or just not as choppy, I guess. Is this, right? 3x squared times the quantity 5x plus 8x cubed plus 3. And if I multiply it all out, you will see that we get to this form. Okay, so that's kind of like the basic idea of how greatest common factor works, all right? In the next videos, we'll be throwing in some harder looks at that and looking at doing it with multiple variables and then looking at grouping. All right, so we will see you there.